Humans have relied on their muscle power, the muscle power of animals, natural forces like wind and currents, and for about 200 years on motors. Humans have been moving on land, on and within water for thousands of years, in the air for about 150 years, and in outer space for a few decades. The invention of the wheel is widely considered a giant step for humanity. This statement is a paradox, because wheels do not step but roll. Steps are discrete, step by step by step. In contrast, the wheels rotate continuously. Rotational engines are relatively rare in living creatures and exist primarily in bacteria. Real wheels did not evolve in animals during evolution, possibly due to their limited mobility in most terrains. You're driving here on a smooth road and you see the infrastructure that had to be built to maximize the efficiency of wheels. Although our off-road vehicles here in Africa manages to move on rough roads, you see what happens when you deviate a few centimeters from the road. It took 6 people 3 hours to get us back moving. Indeed, even with legs you can get stuck, but much less. Thus, the invention of the wheel does not stand alone, but is closely tied to the development of road building technology. Indeed, roads that can be used for wheels have been built since ancient times. The Romans were known to be great road builders. However, paved roads were already built in Egypt and in Ur thousands of years earlier. Until about 200 years ago, all land transportation was based on human and pack animal muscle power. This limited the speed and range of movement as well as the amount of cargo that could be transported. The fastest possible movement was on horseback. The maximum weight depended on the number of pack animals or humans that could be assembled. These pyramids were built from huge blocks of stone, apparently pulled by a large number of workers. The invention of the steam engine in the 18th century led to the Industrial Revolution and the development of trains, which changed transportation forever. A steam engine is based on a boiler filled with water that was heated by burning wood or coal. The pressure created in the boiler is released in a controlled manner and used to produce work. While steam engines were quite efficient for moving trains and ships, they were not suitable for moving carriages or cars. Who would want to light a fire in their vehicle and maintain it throughout the journey? The invention of the internal combustion engine more than 150 years ago paved the way for the development of motor vehicles. Most cars today are still based on such an engine. The heat created by combustion inside the cylinders turns into pressure that pushes pistons. As we already learned, using combustion of fossil carbon fuels has far-reaching environmental consequences that cause climate change and air pollution. Most motorized transportation uses an engine that rotates wheels. However, combustion and its conversion to pressure can create only linear movement. One of the engineering challenges of engines were converting this linear movement into wheel rotation. The way this is done in a car engine is by using several pistons, usually 4, working at staggered timing, or strokes. Moving a crankshaft that converts the various pistons' linear movements into rotational movement, as you see here in the animation. Interestingly, our muscles also perform one-dimensional linear movement. Unlike engines, where the forces are obtained by pushing and pressure, in muscles the forces are obtained by pulling of contracting muscles. The vast variety of body movements is based on creating combinations of different muscles' linear movements. Unlike engines based on burning fuels, electric motors create rotational movement originally. More and more vehicles today are partially powered by electricity, like in hybrid cars, or entirely, like in fully electric cars, which are much more efficient. As long as most electricity is generated by burning fossil fuels, these cars are still causing considerable carbon emission. The environmental impact of driving but not building such cars will further improve once electricity will be generated by renewable energy. Maritime movement also relied initially on the muscle power of rowers, but the use of wind to propel ships is quite ancient. Sailing ships ruled the seas for hundreds of years, reaching impressive speeds and sizes. Explorers and merchants on these ships sailed across all seas and discovered all continents. However, the advent of steam engines and later internal combustion engines enabled the construction of ships of almost unlimited size. The newest form of human movement is aviation. Leonardo da Vinci imagined and sketched flying machines, but the first powered flight was performed by Orville Wright in 1903 in this airplane he built with his brother Wilbur, displayed here at the Aviation Museum in Washington, D.C. The reason it took so long is that although it is very efficient and fast, flying is not simple at all. Unlike all flying animals, planes are not propelled by wing movement, but by engines that push the plane forward, creating lift that raises it into the air and keeps it there. Aviation initially relied on propeller engines, which usually pull the plane forward, or in the case of helicopters, upward. Most planes today are powered by jet engines that push the plane forward and upward. Since we are already here in the Aviation Museum, it's worth taking a look at this spacecraft that reached the moon. Only 66 years passed from the first takeoff by the Wright brothers to Neil Armstrong's first steps on the moon. The launch into space required overcoming Earth's gravity, made possible by these massive rocket engines, which are essentially a very specific type of internal combustion engine. I was 6 years old when Apollo 11 landed on the moon, and I still remember this historic event. There's something exciting and groundbreaking about developing the ability to overcome the gravity that has always dominated and dictates all forms of movement, primarily of walking and flying creatures.